That's why I choose very, almost dark colors such that it grabs attention to the eyes and mind. So if everything is sorted, let's learn something new today. So can you see the topic, Introduction to Measures of Dispersion? Do you remember our last topic?
Statistics.
Statistical measure to manipulate the data. And there we covered, if you remember, mean, median and mode. But what do we call them? All together, they have a name. Anyone who can give me the answer? We call them measure of
central.
No, it's half answer, Kunal. It's half answer.
Measure of central tendency.
Tendencies. Good. Measure of central tendencies. See, as the name, so is the function. Why? Because something to measure, okay, we are okay to measure it. But what is we are and why we are measuring it? Because we want our data to be centered around something by which we can actually learn that how distributed is the data, and are we able to perform any analysis with respect to it or no. This was the aim, to actually learn mean, median and mode. And right today, because you have gratefully understood and gracefully measured each of them, so now is the time to move ahead to understand how the data used to get dispersed and what are the statistical measures to measure them. As simple as that. So dispersion means, can you see this line, dispersion? So this dispersion will give you two things, like a spread, or may I call it distribution. So anyone of you would like to elaborate what do you either mean by spread or distribution, or any one of them? Anyone? See, spread, distribution, even it is visible in right hand side of this slide. If you see, this red bars are lower, then the higher bars are blue, then again we have lowest bar as green and the second last bar as the purple. If you are not talking to me, guys, please mute yourself. Great. So if this is the situation, what you are supposed to see, that out of this west region, this is the any distribution to the west region of a country or say of a state, consider anything, but this is saying to my west region, such analysis or such a dispersion is to this level. Highest dispersion is given by the what is called blue bar, lowest dispersion is given by the green bar, and the second highest dispersion is given by the Mohammed Hussain. Please mute yourself. Mohammed Hussain, please mute yourself. So this is a very simple example of things are spread. Dispersion means you have spread something, like say your consumption of vegetable is shown by red. If I write vegetable, say the consumption of may I call dairy products, consumptions of dairy products is being shown by blue. Consumption of say vegetarian food, no, here vegetables are already been given. Say the consumption of fuel means either petrol or diesel or any LPG fuel is very less, because you guys use say induction or electrical induction, I mean to say, and this is considered say is your expenditure in shopping of, may I call, you are doing a shopping for homely activities. So see the type of dispersion the data set is available with. So this is, we are supposed to measure them, and that's the reason we are getting introduced to the spread and distribution, whereby in terms of statistics we say that in order to measure the spread or distribution, we are bound to learn the variance and a term called standard deviation, because these are the terms which provide insights on how data is distributed about the mean. So mind it, both of them actually are works around the mean value, and mean is represented by mu in statistics. Does anybody have any idea what is the meaning of variance and standard deviation? Yes. Any idea what is the meaning of variance and standard deviation you have encountered in your life, by either by chance or by choice? Abhilash ji, Kunal, any idea? Have you heard about it?
Variance means see amount variance, quantity
Use the
variance.
term, you use the term other than variance. Use the term other than variance. See, start with the English meaning. Mind it, Abhilash ji. Start with English meaning.
Yes.
English meaning says variance means it has come from the term vary. If I take you here, it has come from vary, and it is not V-E-R-Y. It is not V-E-R-Y. This is an adjective which we say very good, very bad, very honest, likewise. No, that is not the vary. Here, vary means variable, ability to vary, ability to change, variability, or I'll distribute it to a very simple meaning, ability to change or ability towards change. Hope it is understood. Means if something is changing, varying, variable, then you have to measure how, till what extent it is variable. Like, say you have a nature that you get upset very soon, but you also recover quite often or quite soon. Say people have such amount of temperament that they get upset soon and they recover soon. So that is called the variance. So the variance is low of their temperament. Are you able to get it? What did I say? Sooner you get, say, usually most of the time you feel good and all of a sudden you will feel bad. So the variability is like this. But if you are happy for a very long time, mind it, if you are happy for a very long time and if you are sad for a very long time even, what would be the, say, physical significance of this? That your variability is not high, means you stay in the position of the mood. You stay either in a happy mood or in an unhappy mood or in an anger for a long time. So you are not varying, you are static most of the time. But sooner, all of a sudden good, all of a sudden bad, all of a sudden saying nothing, all of a sudden enjoying, like doing the say ecstasy, dancing in the ecstasy. So very much variable. I think now I make sense. So if such is a situation, then we have ability to measure that variance in statistics by the name variance. And these two are very much interrelated, must I say. They are very much interrelated. How come? We will just look in a couple of minutes. So we will try to understand the variance, whereby it gives us a proper definition that it is a measure of the spread or dispersion of of the data set. In a very simple language, this is given. The spread, if I remember you, then if I recall you, then we have studied the spread in terms of range. Range means, do you remember the range of any function can be from -7 to say +7? Say this could be a range in which a function is changing. Range could be from any real number to any other real number, and it is given by this big bracket, mind it, big bracket, one real number, say real number 1 and real number 2. So these two real number will give you a range. Like say in your company, the range of salary being distributed is from, say suppose 90,000 to 27 lakhs per month. Okay, suppose I consider this range. So this will be called as the spread. Do I make sense? So you are going to find the variability in the, may I call, the salary structure they given by the HR. So you simply ask the HR, what minimum salary do you give to anyone and what maximum salary do you give to anyone, and don't ask whom you give what, but simply ask this question. So this 90K you found as a minimum salary, and a 27 lakh per month you found as a maximum salary, the highest salary. So you given in your may I say inference that okay, I found 90,000 to be the minimum and 27 lakhs to be the maximum spread in my company, and this will be measuring the variance. So if I plot this variance in say any axis, and say here you have 90K, so very far you will have 27 lakhs. So around 90K, so many people would be there. Do you believe? So many people would be there. So many people would be there. But can you believe that sooner you go with the, may I call, near to the 27 lakh rupees, very few people, hardly 1, 2 or 3 people would be there lurking at 27 lakhs per month. Do I agree? Do you agree with it? Because only the CEO of the company or MD of the company will be fetching such a salary. So can you see the variance, the type of variance you observe in the data set? This is the visualization I have shown you, that in the structure of 90K to say certain lakhs, there's a huge number of people. But when you go to say above 15 lakhs to 27 lakh, the number of people are actually comparatively lesser than that of the previous one. So such a thing, or may I say such a spread, this is called a spread. This is also called spread or dispersion. Senthil, if you're not talking to me, please mute yourself. Senthil, please mute yourself. So this is called spread or dispersion, and hence we are here to actually measure it quantitatively. So I call quantitative measure of this spread or dispersion is termed as variance. Am I understood or no? The quantitative measure is called a variance, not a qualitative, quantitative. You should be dealing with numbers. Please get me the answer. Am I understood? Abhilash ji, give me a thumbs up if you understood.
Yes, I understand.
Okay, thank you.
Contact people, but yes, I understand.
Yeah, okay. You may also give me a thumbs up such that I can view and go for it. Or if most of you can provide me an answer using chat box, so that would be okay. Thank you. Because my focus is on the, may I say, content, not the people here. Because right now, say if I every time look over people who is listening to me, who is watching this right now, then I'll be deviated. Again, a variance in the study will come. So, see, my motive here via taking these classes is that you get those glasses to understand the life, that what is happening around you. If you see any situation, any circumstances, your brain should give a proper indication or a message that this we studied in somewhere, and this is how I can correlate that amount of data to this particular example. Hope my vision is clarified. So I try my best in order to make your mind learn for any time, or say for every time of the life. So if I erase everything, and so this was the definition of the variance, my dear. So it quantifies how far each value in the data is from the mean or average value. That is why we said that variance is actually calculated around the mean. Let me give you a very good example which all of you can correlate with. Say most of you had seen the game of archery. Where people hit the bullseye. Remember bullseye? This is a bullseye. Means you have to, whenever you hit a throw, whenever you hit an archery, you have to hit the bullseye. This is the target. So here our target seems to be, or it is, a bullseye. But it is not possible that everybody hit the bullseye, then everybody would be fetching the Olympics medal for the country, gold and silver, and followed by. So what happens, most of you will be able to, if I change the color, most of you will be able to say someone very good might be able to hit here. Some of you might able to hit here, here, somewhere here, and in the vicinity throughout the circumstances. So this is the situation. There might be only 1 out of 10,000 person who will be hitting very, very near to the bullseye. So the understanding from this archery set is, say your target was bullseye, means the reference point was bullseye. So again, I'll write your reference point is bullseye. But then what should we do with this reference point? The question is this: you are only required to check who hit the target in nearness, who hit the target in fartherness. So say Mr. Abhilash Vishwan hit the target of the third one. This is hit by Abhilash. Say this is hit by Senthil. Say the third one is hit by Kunal, and say this is hit by me. So see the variability from the, or see the proximity of every hit or every archery taken and hitting the bullseye. So for every one of us, the difference from the bullseye, is, say, unique. May I say, is it unique? Abhilashji, is it unique? Great. It is unique. Yes. It means we all are trying to hit the reference, that is bullseye here. But very few or none of us could do that. It means we all are variable. We all are varying from the target. It also says that how far every hit is from the mean or average. So here the mean or average will be considered as bullseye. Hope I make sense, because around bullseye we are hitting the target. Around bullseye we are hitting the target. Here also around the mean we are having the data. Like say if use a different color and show you, say if you can see in the picture, say this is the mean line. Okay, this is the mean. Around this mean your data is distributed. Can you see the distribution of the data, Abhilash, Kunal? Can you see the distribution of the data?
Yeah.
Yes. So here, if this is the data, how the data is distributed, and if this is the mean, so I'll call this line to be a bullseye, and these hitting, which means the distance from the bullseye, is the distribution of the data from the bullseye, and hence we are able to get the variance. How come? We took a difference. From the, or must I say, we took a distance, which is how much distance we have from the bullseye. Say you hit this, so you have a distance of say D1. I hit that, I have a distance of D2. Kunal hit this, so Kunal has a distance of D3. And say Senthil hit this, Senthil has a distance of D4. So all of our is different distance. So if we are sharing a different distance, means we can calculate the variance like the data point, means the exact data point, minus the mean mu. I represent mean by mu, and variance is not given by the only distance difference, or may I say difference of the distance. It is given by the squaredness of the difference. Means first you take the difference, then you square them. Sooner you square them, you also take summation, and you apply the, what is this, mean. So what are you doing? This formula is actually calculating the variance, which meant to be summing the squared difference, summing the squared deviation or a difference by the, say, from the mean, and then dividing by the total number of data points. So this is how it is being represented in statistics. Let me give you a proper reference. If I erase everything, can you see the calculate variance formula here? Yes or no? This is called sigma square.
Yes.
Sigma square is termed as variance. Why sigma square? Because of the term square it contains. And because there is a square term, so even in the calculation, the square term will be calculated. Like say suppose, if I draw the line of mean, consider this is a mean line, this is a line of mean, and I take certain points which are variable from the mean, so which are varying from the mean, say like this. So how to calculate it? It is a very fantastic thing and easy thing to understand. Let's see. Please have a look. You simply calculate the distance of every point from the mean. As simple as this. I think it is easy to calculate a distance from every point from the mean. Yes or no? Abhilash, is it easy or no?
It's not easy. A very political question.
Well, it looks easy. Means it is not tricky. It can be done using machine. I'm not saying you go and do it, calculate the perpendicular distance. You have to give the instruction to the machine.
Okay.
So see, anything which a brain can visualize can be done. I hope you got my point. You visualize something and it happens to in your life.
Yeah, I got it.
You can, so likewise, hereby you are only calculating the distance from the distance of all the distributed points from the mean line. Then after doing this, the only task is, say you calculated first x1 minus mu, but you took a square of it. Then you calculated a difference of second point from the mu, x2 minus mu, and then you took a square of it. Similarly, x3 minus mu and square of it. And it goes on till the number of points, say n point are there. Say xn minus mu. See, mu is not changing. Mu is same. Mu is very same. But x are changing. So such things are called, my dear, it is called as squared difference. So you are adding a squared difference here. Do I make sense now? Adding a squared difference. We will see why the squared difference we are adding, not the why did we took a squared difference? Why not did we took anything which is making it a positive number? Because what do we do? Say we have -4, and to make it positive, if you go for square, it will become positive but becomes a 16, isn't it? So to make anything positive, we have a choice of squaring. We also have one more choice, but that has a problem. We will see just in a couple of minutes. So hereby square difference is taken and then added all together. So sooner you add all together, and after adding them, you are dividing that particular addition by the total number of data points. Say suppose there are n number of data points, so you are dividing it by n. As simple as this. So this is the mathematical answer to variance. So I tried to display the variance in two forms. One, qualitative way, bullseye. Second is quantitative way, with the help of formula. So then the question comes, then why not we are going to use the anything other than square? So the answer to this is in this slide. Say I'll use this slide for the reference. I'll take this here. Okay. So see, why did we took a square difference? If we just add up the difference from the mean, what happened? The negative cancels the positive. Say suppose here in this example, minus +4, +4, -4, -4, 4 points are there. Out of these 4 points, actually this is not the point. This is the distance between the mean value and this any point. Can you see? This is the distance. +4 is the distance. So let me give with proper color. Say if I use a red color. So this is called +4. This distance is also +4. This is a distance of -4 and a -4. Hope now it is clear now. Yes, it is clear. Sooner, say suppose if I do simple addition, suppose what I do, I simply add +4, +4. Now this is the squared, sorry, this is the difference value, difference from the point to the mean. So first difference is 4, second difference is 4, third difference is -4, fourth difference is again -4, divided by total number of points, which is again 4, coincidentally here 4. So what happens? Cancels each other. Can you see? Cancels each other. So this becomes 0. So if we are only adding them algebraically, simply add them, there are situations when a variance is not even visible because the answer becomes 0. Say if I ask you, Ki Abhilash, say if I give you value of variance is 0. Suppose if I ask you and give you this question, will you be able to say that if a variance is 0, then how far the points should be from their mean? Give me any answer. All of you. Kunalji, even this is for you. Say, I said, if your variance is 0, how far your all the points would be from mean? How far? Any idea?
How far means
Zero.
0.
How far means 0 means there should not be any distance between the mean and the points. Yes or no?
Yes.
Yes.
That also means that all the points, say suppose this is the line of mean, so this also means that all the points are actually lying on this line. Am I correct?
Right.
So variance equal to 0 most of the time gives false impression of that all the points are over the mean. That is the reason. Can you see here? The points are there. There are +4 difference and -4 difference. There is a spread. There is a distribution, but still the mean is 0. If you simply add them, can you see? If you simply add them, divide by 4, it gives you impression that a variance becomes 0. That is one reason that we do not take variance as a x1 minus mu plus x2 minus mu and so on. Means only a simple difference. We do not take that because this is the shortcoming, limitation. If we do that and by chance the variance goes 0, false impression will be created. Okay, if that is not done, then why don't we take the, may I say, have you heard about absolute function? If you go for -3 and I apply the modulus function to it, absolute function to it, it will turn this -3 to +3. Have you heard about this? Yes or no? Have you heard about this or no? Kunal, Abhilash? No. Okay. No worries. If you have not heard about this, there are functions in mathematics. We call them modulus function. Modulus function. Modulus function says that it has the definition which says I am plus x when the value of x is greater than or equal to 0, means any positive value, but I would be treated as minus x when x is less than 0. What is the meaning? The meaning is, say you have +4. So is it greater than or equal to 0? Yes, it is greater than or equal to 0. It means then x will be, sorry, mod x will be considered as +4 only. But by chance, if this x is -4, I have taken a -4 point, this value is actually less than 0. So now this, yeah, now this mod x will be treated as -x. And what is the value of x now? -4. So minus of -4. So this will be converting into +4. So hence modulus function has the ability to change any negative value to a positive value. So it is good that you acknowledged at this point that you did not knew the modulus function, because in my classes, especially to all the students, the modulus function had priorly been explained. So maybe in today's few classes, you guys are quite new. So no worries, it's my responsibility to continue with along with that. So always remind this. If this is the situation, then I would say that looks good and is the mean deviation. But what about the case it also gives a value 4 even though the difference is more spread out? Let's see how. I'm erasing everything and I now say, okay, you did not took the, say, negative and positive here. Negative cancels the positive. and giving the false impression, but that won't work. But how about use the absolute values? Why did not we use the absolute values? Means again, mod of x. This is the meaning of absolute values. Then what's the problem with that? Let's look at it. So that looks good, but what about this case here? If you use the modulus value here, plus 4, already plus 4, great. But say if I add them, plus 4, plus of minus 4, plus of minus 4. Why I'm doing that? Because of modulus is applied over them, divided by 4. So this add up to 4 plus 4 plus 4 plus 4, 16. 16 divided by 4 becomes simple 4.
4.
But now come to this plus 7, plus 1, minus 6, and minus 2. Apply the same rule to it also. So plus 7 becomes 7, plus 1 becomes 1, minus 6 becomes plus 6, and minus 2 becomes plus 2. Divide by 4, because 4 elements are in. So 7 plus 1, 8 plus 2, 10 plus 6, 16. Oh my God, 16 by 4. What is this? Still
4.
the variance is 4. See here,
4.
for the above, for the above example, the variance sigma square is 4. For the below example also, the sigma square is 4. Is it justified that in the above example, the variance, or can you see the spread is equal? The variance is equal, the spread is equal. Plus 4 unit, or a 4 unit above the mean and 4 unit below the mean. But here in the next scenario, if you check it here, there is a, see the difference. 7 unit above the mean, 8 unit above the mean, 6 unit below the mean, 2 unit below the mean. But the answer is showing that a sigma square for situation 1 is same as sigma square for situation 2. Is it justifying? Give me an answer. Is it justifying the spread? Have you got the question? Asking you, is it justifying the spread? At one time,
Tell me.
you are having 4 points, sorry, 8 points above, sorry, 8 points above the mean and 8 points below the mean. 4 plus 4. It is having a variance of, or a spread of 4. And hereby, if you check here also, if I change the color, here you have 8 points above the mean and 8 points below the mean, and still the variance is same. Why is it so? It is also not able to justify the, may I call, equation or mathematical equation of a variance. Why we are discussing it? Because we started with a situation that why did we took the squared difference? Why not the negative and positive did work well, and why not the mean deviation is working well? Okay, why not mean deviation is working well? This is what we are saying. So the answer to this is the positive and negatives were cancelling each other. They were cancelling each other and creating a false impression of zero variance. False impression of zero variance, whereby when you went for the mean deviation means going for absolute values, mod of sigma square. Here it gives a value of 4, even though the differences are more spread out. Can you see the differences? Here the differences are 4 upside down, but here see the difference. Because what the variance is all about, it's all about difference. It's all about spread. It's about how far the point is from the mean. So here, all the 4 points are same distance apart from the mean. But in the second scenario, one point is 7 point apart, one other point is single point apart, third point is 6 point apart, and the fourth point is 2 point apart. So here the system should signify higher variability, yes or no? Higher variance or a higher variability. Am I understood? Please.
Yes, sir. Yes.
Yeah. Sanesh, you joined late.
Yeah, late. Sorry.
See, I explained variance in detail. So please look on the may I call
Video,
what is
video.
that?
Video.
Yeah, please. Yes,
Okay,
please
okay.
look the
Sorry,
video.
Sorry, I late. I
Yeah.
actually stuck in block.
Okay. No worries. Are you well? I hope things are good with you.
Yes, it's good.
Okay, chalo. So this is a high variance variability points here. That is the reason, my dear, we are taking the squared difference. What is that? The squared difference is because mean is constant. So first point, difference from the mean, and we also want a positive value. We don't want a negative value because it was cancelling each other. Remember here, it were cancelling each other. So we want positive value. The mean deviation did not explain the spread. So we are bound, or we have no choice other than taking the square while calculating the variance. So again, we will take the squared difference from the mean. Third point is squared difference from the mean, and so on till number of points reaches xn minus mu whole square. Now, sooner this is done, this is only the addition of the points. Now you have to write n. N is the total number of data points considered for the situation. Hope this helped you. So here it is being shown calculation of the variance. This n is for the, see, there are two, may I say, there are two, what is this equation for variance. The capital N shows that this is belongs to population. This belongs to population. Whereby if it is n minus 1, this belongs to sample. This belongs to sample. Now, my next question is, does all of you know what is the difference between a sample and a population? Kunal, any? Because you seem quite listening. Oh my God, what is happening here?
Is some complaint I am attending. That's why.
Okay. You are multitasking. You are multitasking right now.
Yeah,
Okay, carry on. No worries. Okay. The question I asked is, any doubt between population and sample? Does all of you know what is the difference between a population and a sample? Say if I give you a reference, say you want to do a survey for one whole state, and you want to find the average height of male people, the people who are male in a city. You want to find the average height of male in a city. That is your task. So is it possible for you to go to every male and ask their height? Is it
Very
possible?
difficult.
Very difficult, almost impossible. You will throw all your instrument down. You know, this I can't do. But there is a possibility in statistics. We say that please collect the enough sufficient people such that their height should represent the effective height of the, or effective average height of the all the people in a population. So this sample would indicate, say suppose this is a population where a population of a city of a male people, say they are around 12 lakhs male, suppose 12 lakhs male people are, male citizens are there. So out of these 12 lakhs, if you are able to hardly take 1.2 lakhs of people, this is possible if you do certain efforts. 1.2 lakhs of male citizen, if you take a sample of 1.2 lakhs and takes the average height of these male citizens, so this average height, if I say, this average height should represent effectively, or it should be able to represent the population average height. Like you sometimes become a CR, class representative in your classroom, and you represent the whole class. You get the benefit and you get the curse. If something happens, CR will be penalized. If something good happens, CR will be rewarded. So the whole class was represented by class representative. So that is the best thing to consider a population versus sample. But in statistics, one single guy do not represent the whole population. You have to take few persons to represent the population. So why I am raising this question here, my dear, whenever a population is considered, say you are given a population, consider capital N, this formula. But whenever a sample is given, say it is written in a question that consider the sample of 3,000 people, then in that case, your denominator should not be 3,000. Your denominator should be 2,999. Am I understood? Yes. Because here we have n minus 1. Answer will change. So this was my motive to let you explain this thing such that you understand it quite well. So hope I would have simply added a value to your learning and life via this. Any doubt from the past classes if you have, because right from now we will be covering the different topic that is called as standard deviation, and standard deviation again starts a fresh starting. So what are the challenges you are facing in your, say, means in your professional work benches? Any challenges, Abhilashji, you are facing? You seems to be a very